Okay, we're moving on to section 22.2, charging objects by induction. Let's share the PowerPoint and let's read the little square here. Electrical conductors are materials in which some of the electrons are free electrons that are not bound to atoms and can move relatively freely through the material. We have electrical conductors like copper, aluminum, silver, even gold. If you look at some of these edge connectors, they're gold plated because not because there are conductors that are better than gold, but gold is non-corrosive, so it lasts longer. And when you charge, if you were to charge a conductor, the electrons or the charge spreads evenly over the conductor. That's they're free to move, so the you, the if it's got excess electrons, then the electrons will repel each other and they scatter throughout the material. Now, electrical insulators are materials in which all electrons are bound to atoms and cannot move freely through the material. Glass, rubber, dry wood. Now, if you were to charge them by rubbing, as we showed in one of the previous slides, the only the area that is rubbed becomes charged. The charged particles are unable to move to other regions of the material. So electrical conductors, charges move freely. Electrical insulators, charge does it inhibits the movement of charges. Um, okay, then we have an area in between. Semiconductors, silicon, polycrystalline germanium. These are a third class of materials between conductors and insulators that they're used uh, in fabrication of electronic chips, um, computers, cellular telephones, home theater systems, uh, and the electrical properties of semiconductors can be changed over many orders of magnitude depending on the the potential, the voltage that you put on them. So there, uh, you can control you can control them, and you can also dope them by either putting extra atoms into the it has controlled amounts of atoms in the material. Uh, okay, now let's talk about charging objects by induction. So in A, we have a neutral sphere. It has an equal number of positive and negative charges. Um, so if you bring a charged rod close to the sphere, then in this case the rod has an excess of negative charges. Um, so the negative charges on the sphere are going to migrate to one side. They're going to be repelled by the charged rod. Now, if you were to take a wire and touch it to ground, a wire attached to the sphere, and touch it to ground, uh, we'll learn about ground later. Some electrons leave the grounded sphere through the ground wire. Now, when you remove the ground, the excess positive charge is non-uniformly distributed because you still have the rod next to it, and we're talking about in D. This is in D. Now, if you remove the rod, the charged rod, the remaining electrons redistribute uniformly, and there's a net uniform distribution of positive charge on the sphere. So this is how you charge a an object by induction. Notice you don't ever touch the sphere with the charged rod. It's just by induction. Okay, charging objects by induction. We're continuing. Um, this is the balloon trick that I tried to do at the beginning. I think it worked a little bit. It slid slowly. The charged balloon induces a charge separation on the surface of the wall due to the realignment of the charges in the molecules of the wall. So when I rubbed it on my hair, I stripped off some of the electrons, and it became positively charged. You put it up to the wall. The wall there's an induced charge. In other words, the electrons are forced towards the surface of the wall, and they attract the balloon. So there's a realignment of the charge. It's going to stay neutral, but there's a realignment of the charge just because you're bringing the charged balloon up to the surface. Now let's look at a quick quiz. 3 objects are brought close to one another, 2 at a time. When objects A and B are brought together, they attract. Okay, A and B attract. They could either be positive or negative, or reverse it, negative and positive, depending on A and B. Or one could be neutral, as we just saw in the previous. The wall is neutral, but it's attracted to the balloon is attracted to it, even though the wall is neutral. So A could be neutral or B could be neutral. They attract. Now, when objects B and C are brought together, they repel. Now, if B and C repel, they have to be charged. Are they charged positively or are they charged negatively? Well, we don't know. Which of the following are necessarily true? Objects A and C possess charges of the same sign. We don't know, because A could be neutral or B could be neutral. Objects, well, probably not B because they repel. Objects A and C possess charges of opposite sign. We don't know that because A could be neutral. All 3 objects possess charges of the same sign. Obviously not, because when objects A and B are brought together, they attract, and they have to be of opposite signs, or one of them is neutral. Well, probably A could be neutral. One object is neutral. Well, A could be, but it also could be, it could have an opposite charge. So the answer is additional experiments must be performed to determine information about the charges on the objects. Okay, and that ends 22.2. We'll go on with 22.3, Coulomb's law in the next slide, in the next lecture.